Good morning, students. Now, today continue online class B.sc Maths second year, and then subject is Mathematical Statistics 1. Multiplication theorem of probability. Statement is for two events A and B, P of A intersection B equal to P of A plus P of A into P of B divides A, comma, P of A greater than 0. Next is equal to P of B into P of A divides B, comma, P of B greater than 0. This is the equation number 1, where P of B divides A represents conditional probability of occurrence of caps B when the event caps A has already happened, and probability of A divides B is the conditional probability of happening of caps A given that caps B has already happened. Proof. In the usual notations, we have P of A equal to N of A dividing by N of S, P of B equal to N of B dividing by N of S, and P of A intersection B equal to N of A intersection B dividing by N of S. P of A divides B equal to N of A intersection B dividing by N of B. P of A intersection B equal to N of B dividing by N of S into N of A intersection B dividing by N of B. P of A intersection B equal to P of B into P of A divides B. This is the equation number 2. Similarly, P of A intersection B equal to N of A dividing by N of S into N of A intersection B dividing by N of A. P of A intersection B equal to P of A into P of B divides A. This is the equation number 3. From 2 and 3 we get the proof. This is the important theorem. Next definition: independence of events. An event A is said to be independent or statistically independent of another event B if the conditional probability of caps A given caps B, that is P of A divides B, is equal to the unconditional probability of B, that is if P of A divides B is equal to P of A. Next theorem, important Bayes theorem. Statement: if E1, E2, E3, etc. En are mutually disjoint events with P of Ei not equal to 0, I is equal to 1, 2, 3, etc. n, then for any arbitrary event caps A which is a subset of union I equal to 1 to n Ei such that P of A greater than 0, we have P of Ei divides A equal to P of EI into P of A divides EI dividing by summation I varies from 1 to n P of EI into P of A divides EI equal to P of EI into P of A divides EI dividing by P of A I equal to 1 to n equation number 1. Next proof. Since A contains I varies from 1 to n ei. Since A contains union I varies from 1 to n ei, we have A equal to A intersection union I varies from 1 to n ei is equal to union I varies from 1 to n A intersection ei. Since A intersection ei contains ei, I values 1 to n are mutually disjoint events. P of A equal to P of union I varies from 1 to n A intersection ei is equal to summation I varies from 1 to n P of A intersection ei. P of A equal to summation I varies from 1 to n P of ei into P of A divides ei. Next, also we have P of A intersection ei is equal to P of A into P of ei divides A. P of ei divides A equal to P of A intersection ei dividing by P of A equal to P of ei into P of A divides ei dividing by summation I varies from 1 to n P of ei into P of A divides ei. P of ei dividing A is equal to P of ei into P of A divides ei dividing by summation I varies from 1 to n P of ei into P of A divides ei. This is the formula. P of ei divides A equal to P of A intersection ei dividing by P of A. And then formula is P of A divides B equal to P of B intersection A dividing by P of B. This is the formula, and then using this step A value is ei, B value is A. So P of ei divides A equal to P of ei into P of A divides ei dividing by summation I varies from 1 to n P of ei into P of A divides ei. That means probability of first element dividing by second element equal to probability of first element into probability of second dividing by first element dividing by probability of first element into probability of second element dividing by first element. First element value is A, second element value is A. So hence the proof. Thank you, students.